Yeah, hello, Subbu. Okay, today we are going to solve the problem of CSES sheet graph problem, which is building roads problem. Here, the problem is said that Bikeland has n cities and m roads between them. The goal is to construct new roads so that there is a route between any two cities. Your task is to find the minimum number of roads required and also determine which road should be built. So the input pattern is like that the first line has two integers n and m, the number of cities and the number of roads. After that, there are m lines describing the roads. Each line has two integers a and b. There is a road between those cities. A road always connects to different cities, and there is at most one road between any two cities. First, so what we have to output? We have to output an integer k, the number of required roads, and then k lines, which describe the road we have to build. So, what do you think about this problem? You have to think like a graph approach, as it is a graph sheet. So, think in that way. Like it looks like that some of the cities are connected. I mean to say that maybe it is possible that three cities are connected. Let name them one, two, three. First city, second city, and third city is connected. And the fourth, fifth, and sixth city is connected. So there are two connected components, but there is no connection between the third city and fourth city. So how we go from third city to fourth city? So we have to build one road. Let's take an example, like here. Here there is a road between 1 to 2 and 3 to 4. But there is no road between 2 to 3 or 2 to 4. So we can go from 1 to 2, but we can't go from 1 to 3 and we can't from 1 to 4. So think like that it's a component. I mean to say that let's make a graph of this problem. So 1 and 2 are connected. We can assume that it is a undirected graph. So there is a age between 1 and 2 and there is another age between 3 to 4. Now, when you make this graph, you clearly see that there are two components. Or what we have to do, we have to just connect this component. So the number of rows is equal to the number of components minus 1. Left in this example, we can easily see that there are two components. In the one component, 1 and 2 are present, and in the second component, 3 and 4 are present. There are two components, and the number of cities we have to, sorry, I have to say that the number of roads we have to build to connect these cities are 1. So it can be, the road can be from 1 to 3, 2 to 3, 1 to 4, or 2 to 4. Doesn't matter that which road we build, but we have to build one road between these components. So how will you solve this? So we are going to solve this by DFS approach. Yes, I have made this common function that is so common for all. Here the test cases are 1, so I will take the t as a 1 and will take as an input the input are n and m. Okay, so I'm taking input as n and m. Then I have to take a input the rows. So vector, and there are n rows, so the there are n cities. Okay. You can tell me why you will take it as a directed graph, because there is no explicitly mentioned that the roads are unidirectional. We assume that roads are bidirectional. It means we can go from 1 to 2 and 2 to 1 also. or you know that when this type of case is present in the graph, like we can go A to B and B to A by a single A, then the graph will be a directed graph. Okay, that's why I will take it as a undirected graph. Now, for every, we will take what we will do. We will just find the connected components. Okay, and then for each connected component, let we have two or three connected components. So for ith connected component, we build the road between I connected component and I plus one connected component. So we will store it in the vector, and we will take it as a visited because we are using the DFS approach to find the connected component. As we know how to find the connected component, if you don't know, I will tell you. So here we are iterating on every city. Now I'm checking here. Is it possible? Is the IS city is visited, or is there any road previously we meet by which we can reach to the IS city? If it is not, then we will uh, travel on this road. We will apply DFS for this road and check that which component of this road belongs to. Okay, and we will take as a vector component in which we are storing the component. So if there is none another component present from which we can reach to the ith row, so we will make it as a new component. That's why I will push it this road into the this city into the component vector. Okay, and now apply DFS to find that the number of roads that we reach from this uh, is city, because these cities are also the part of the this component. So apply DFS. We pass the city and the visited component and our roads that are available to us. Okay, we will take it as a void, our node, and our visited component, and our available roads. Okay, so what we will do, basically we will mark all the roads, all the cities as visited, which can be possible to travel from the IS city. Actually, what we will do, we will mark all the cities visited or all the cities are reachable that can be reached from the city I. If I can reach the I city to less X city, if I can go I city to X city, so I have marked the city also visited because it is a part of the component, and in the component vector I already pushed the IS city. You don't need to push back again it. Okay, so utility is mark all the cities as visited that are reachable from the highest city. Okay, now if it is not already, if it is already marked, we can mark only if it is not marked already. Okay, so visited of node is equal to 1, and then go to its child and apply df. Again for the child, so oh, you get it, and then finally we will return. So what we will do here, we will mark all the cities that can be reachable from the IS city. Okay, now what will I tell you that the number of rows we have to build is equal to the number of components present in our graph minus 1. So in we will apply it equal to component dot size minus 1. Okay. and we will print also it. Uh, Now we also have to tell that the number of the road we have to win. For this one, we will win the road between the ith component to I plus 1 component. So I will traverse from 0 to component of size minus 1 and build the road between the component of I to component of I plus 1. So assume like that there are three components. So the first one component is 1, second one is second, and the third one is third. Okay, and the other roads are the part of this component. So what if I build the road between this component and second component? And second component and third component. So after this, we don't need to make a road between first component to third component because we can travel from first to second and second to third. So we don't need to build another road. So that's why, and we have to minimize also the number of roads. So that's why this is our answer. And then last, so let's test it on the sample test cases. Anything? Mhm. Okay. It will be a n plus 1 because it is a one based induction, not a zero based. It's okay. I will have to tell from 1 to n plus 1. That's the problem. And I have to have this from n plus 1. So as you can see, I have to build one road and it is 1 comma 3. It means we have to build the road between the city 1 and the city 3. Okay. So let's submit it. This is what problem. Hmm. What's the problem? User test. Is two problem. What next? We check what the problem. Let's see that it's a wrong output in the larger test cases. So maybe it's a long, but actually there are M roads, not N roads. There are M roads. I will take only and then put N roads. That's the there are N cities and M roads. That's the problem. Submit it again. Vote and submit it. Now wait for the result. Yeah. Okay. So thank you. I have attached my GitHub repository for if you need the code and like the channel, subscribe the channel. Thank you for your